Right. Good evening, everyone, and welcome back to day three of learning about OOP concepts in Python. Now, object-oriented programming is a practical way of dealing with Python, which allows us to avoid repetition and just work overall towards enhancing the way we look at any kind of code. Now, as part of our object-oriented programming, we're looking at classes and objects, which is our primary area of focus. Okay. Now, today we're going to try a different approach of utilization for our object-oriented program. Okay. What we're going to do is we're going to look at some kind of a data set. Okay. So we'll use this data set to then create a class which will allow us to perform our EDA process. Okay, that is what we are trying to understand. So we will have the libraries we want to use. So we'll say import pandas as PD, import matplotlib dot pyplot as plt, import cbon as SNS. So these are the libraries that I want to use. Okay, so we load all of the libraries. Now, after that, we want to give the file path to the data set that I want to use. So let me get that file path here. You will just give me a second. Now, the idea here is very simple. We want to take our data set. Okay, and we should be able to process that data set. Okay, so we will take our data set here. Okay, and we'll just use our pandas to read the data set. Okay, so this is all the basic stuff that you would already. Okay, and here we have a data set that we're looking at. It's a fairly simple data set that we are trying to work with. Now, what we want to do next is we want to take this fairly simple data set and we want to perform EDA on this data set. Okay, we want to understand the different EDA processes that we will take. So let's define a class. All right, and you can call that class whatever you want. Okay, so we will say class, we will call this class EDA. Okay, done. Basic EDA definition created. Then next, what we'll do here is within this class, we will start writing a standard process code. We will write the init function. Within the init function, we will take the data frame as well as the call for self. Okay, let's say self.df goes to data frame. So this is the input that we want to give to our class. Whenever we want to call the EDA class, which will contain some steps that you will take for doing EDA, you will try to call this data frame. Now, here we will start by looking at our analysis that we can do. Okay. And the first function that I'm creating here is a very simple function that will display, and I will give them logical names. Okay, display descriptive stats. That is what I will call this function here. And here again, the input within this class object is going to be a self. Now here, what I'll do is I will start using my doc strings. Now, so I'll create a doc string here. Display the basic statistics of the dataset. Okay. The stats on display include mean, standard deviation, we will add min, max, count, 25th, 50th, 75th percentile values. Okay, this is what we will do. Now, if you want to further enhance your learning experience, you can try to do all of this process without using any kind of Python libraries. Okay, but that is not always required. Okay, and make sure to close your doc string properly, always. Okay, and here we'll simply say return self.df.describe. Okay, and this will return the descriptive statistics for us. Then the next thing that I want to look at here is missing values. Okay, so again we will create a doc string. This will check the missing values in the dataset. It will return the sum of missing values. Okay, so here again we will say return self.df dot is null dot. So we're just writing the code, basic code here. Okay, so this is all some basic stuff that we will do. So let's just try and utilize this and see how we can get it done. I will create an instance of my class ADA and I will pass the cards dataset to it. Again, we can check what ADA is. You can see that it is a class instance. Okay. Then here we'll take basic underscore stats. This is going to give EDA dot, what is the name of the function? Display descriptive stats. That's it. Similarly, I can check for missing data, right? And we will say EDA dot missing underscore values. And then we can simply just say print basic stats. Okay, great. Here, need to pass self as a value here. And here you can see that we are getting the basic stats. Okay. Now, you must be wondering here, hey, like, okay, you are trying to do some EDA steps and you're writing a function and then you're calling that, you're writing a class, you're calling that class, and then you're running all of that code. Wouldn't it be easy to simply just say cars.describe? Yes. But it is not for those things that I am creating my class. Okay. Now, what I want to do here is I want to enhance my code here. Okay. And what I will show you is how we can create complex function, complex objects, which will allow easy repetition for us. Okay. So here, let's create another object here. As I said, plot histogram. And this will take the histogram as a parameter. Okay. And again, we'll say plot the histogram using matplotlib as a base library. Okay. So here we will say self.df.hist. Okay. And let's say the bins that I want here is 10. And we will say fixed size. And we will give fixed size as, let's say, 15 by 10. Okay. And then we will say plot.speed title, which is a histogram for numerical features. Okay. And then I will say plt.show. Done. This is still working. And here we will say hist equals to EDA dot plot underscore histogram. Okay, you can see here that histogram is getting plotted for all the columns. Okay, now again, you might be wondering here that, okay, you know what, that is all fine, but how does this benefit us? Right? Like, how is this useful for me? What can I do with this that I cannot do with anything else? Why do I need to, specifically do something like this? Why can't I just, go ahead with the normal data set and just do all of that work as a normal value? Why do I need to specifically create my classes? The reason for that is very simple. Okay, because we will be trying to improvise for different data sets. Okay, so that no matter what you're looking at, you're always going to have the ability to process the information faster. So here, let's say that I will create some data. Okay, and again, I will pass another CSV file, which is quite similar to the CSV file that we have already passed, right? Quite similar. Here, let's say hist1 equals to EDA. We have already created this instance for this cars dataset. So let's create another instance here called EDA1. And in this, I will say data. Now, EDA1 dot plot underscore histogram. This is the name of the object that we are calling. We'll run this. And there you go. Now, I can just quickly look at my 2 data sets and I can do a quick analysis. And the benefit here is that I don't have to write codes again and again. I can just simply use the first code that I have created and apply it on different data sets. Okay, I can apply it on any number of data sets that I want to use it. And this is histogram. So this is going to take a total count of categories, right? So let's add some more functionality to our class. Okay, let's try to add some more values here. Something that can help us understand our information even better. Let's say I will check for my correlation map, plot correlation. And here we will plot our correlation value and we'll say this correlation map is created using matplotlib and plotly C1 library. This will help you to establish basic dependencies across variables. Okay, done. So now I want to create a check for my correlation. Okay, so I will use matplotlib to create a figure and we will give it some figure size and we will say this is 10 by 8. Okay, and then I will use my C1 library. And here I will first call my data frame and I will check for its correlation. I'll say annotate equals to true. CMap was to just give some kind of color map that you want to go with. Okay. And yeah, that's it. Okay. Then we can give this some title and we'll say correlation matrix. This is the title that I'm going with. Okay. And then I'll do plt dot show. Again, this is the now. I'll try to add one more plot here. Okay. Just to drive home the point about the utilization of my object-oriented programming concepts here. And the plot that we will be looking at is my scatter plot. Okay. Of course, you can do many other things. You can check box plot, you can check for normal distribution and everything. You can just create a class, right? Just create a class for all steps and then just call it. And this is exactly how libraries work, right? We have looked at so many different libraries and we have so many different parameters. The libraries check. All of these parameters that we use and create, this is what our classes and objects do. Okay, this is exactly what objects and classes do. Exactly the same thing. All right. So you're just recreating what libraries do to make your life easier. Okay. You're just trying to make your own life easier here. So let's create a scatter plot. Okay. And again, we will say this scatter plot will be created using matplotlib and cbum libraries. Okay. And then if you want to give further explanation, this will visualize the correlation between different variables. Okay. And then we can start writing the function. Again, I will say plt.figure will create an empty figure here and we'll give it some figure size. And then I will call my scatter plot using my cbum library. Here we will access some column here on X, and we will access some column here on Y. Okay, X and Y is created. Then I want to add a title here, plt.title. And I will say scatter plot for, then we will call our X column here, and we will call our Y column here. Okay. And then we can just add some label values here, plt dot label. I need to close this formatted string here. So we'll take the X column and we will take the Y column. And then we will just do plt dot show. So this is how our class is going to be created. Okay, you can see it's very neat and clean, very easy to understand. Okay. And then here, what we'll try to do here is say help ED. Okay. And you can see this documentation as well. Okay. So again, I will re-initialize this class. Again, I can create the different data frames. Okay. And here we will also take a look at, let's say, some scatter plot. Okay. So let's first use my plot correlation function here. Right. So I'll say correlation equals to EDA dot plot correlation. We'll plot the correlation value and we can see here the correlation that we are having, right? Similarly, I'll say scatter here is EDA dot plot underscore scatter. And then I have to give my column names because it is expecting some kind of input as my column name here. So we will say HP and we will say MPG. Now, here you can see we are getting a type error. That's because when we are creating a scatter plot, it is expecting that we will give some value. We are creating it in such a way that it is expecting that we will give some kind of column names, right? But if we go ahead and take a look at a class definition, and we are just going to refer to the documentation here. Look at this. How many arguments in the object? One. That's it. One. So we need to create more arguments. Okay. So here I will take the argument as x call and y call. Obviously, we are passing some arguments here, so it has to have certain values which we are going to give it to. Now, if you look at it, the number of arguments that we are having is 3. Okay. And then we will recreate this instance of our cars data, and we will do the scatter plot. And we can see the scatter plot value here. Okay. So this way you can try different ways in which you want to work with. So for example, here I will take this data. This is a different data. This is somewhat similar, but slightly different if you see here. Okay. We will do the basic descriptive statistics here, and we can plot the histogram for this data. And here you will see the histogram for this data. Similarly, I can also say scatter1 equals to EDA1 dot plot underscore scatter. And then again, we need to pass the column name. So we will give some column values here. So let's say, we will say WT, and we will use displacement, weight and displacement. Okay. So here we have our scatter. Okay. So this is how we are going to use our classes to help in EDA. Okay. We can also use it for preprocessing. We can use it for model building and evaluation. This will allow us to generalize our codes so it can be used in different places. Okay, so we have covered about the basics of our classes and objects. However, we still have quite a few different topics directly related to core Python, which we have to cover. So we're going to start looking at concepts such as encapsulation, inheritance, polymorphism, abstraction, etc., starting from the next session onwards. We're going to talk about how we can use those concepts to enhance the quality of the code that we are writing, and how in the long run using concepts like those are actually beneficial for us. Okay. So this is how it is going to. Right. So thank you so much to everyone who has joined in today. And I hope you had a great learning experience, and definitely look forward to seeing you guys again next week. Thank you. Bye-bye.